Student Heights versus Shoe Size by Jessica Haywood. Introduction to the ISP. For my grade 12 math ISP, I decided to choose a topic comparing student heights to the measurements of their shoe sizes. I chose this idea because it was information I could collect from peers around myself and it could be easily obtained. The information will always be varied depending on who I ask. For example, if I were to do another survey on the people from a different grade 12 class, their heights and shoe sizes would be unique from the numbers in this class. I found it interesting to research this topic due to its uniqueness and to see what standard deviations, variances, and measurements everyone has. I used primary data which I collected myself, knowing they are true numbers, and I surveyed everyone who was around me. My hypothesis. Once I found my topic of heights versus shoe sizes of students, I began to hypothesize thoughts. I first thought of their shoe sizes and how their heights depended on these measurements. I believe that someone with a shorter height would basically have a petite foot size, and the opposite for a taller person in having a longer shoe size. After collecting my first and second variables, heights and shoe sizes, I realized my guess was sort of not exact with the actual information. Data collection. To collect my data, I surveyed 25 peers who were willing to provide their information to my ISP assignment. I first asked if they would participate for my data collection, and the usual answer was yes, they did not mind. I would then start the survey by asking if their height in either centimeters or feet. Centimeters was more encouraged, but I did have to convert the numbers myself sometimes. Their heights were diverse between 150 and 188 centimeters tall, and their shoe sizes varied from size 4 to size 12. Overall, I did not have any issues obtaining any data for my assignment. The chart of heights in centimeters versus shoe sizes. The left columns in each chart is the heights in centimeters, and the right columns are their shoe sizes. Data variable 1, heights in centimeters. Analyzing the data, I compounded the work down into 3 sections, variable 1, variable 2, and then both the data put together. In the first variable, heights of students, I measured the mean, 169.2, the median, 167.5, and the mode, 162.5. The mean told me the average between the heights of 150 and 188 was 169.2. The median is the middle number of the data collection, which was 167.5, and the mode was 162.5. This tells us the most common height in students. Histogram for variable 1. This histogram shows the heights in centimeters of students. It represents how many people are at each height, such as there are 2 people in between the heights of 150 and 158. This graph also shows that the distribution shape of data is positively skewed. This means being more weighted than the median and mode. Variance and standard deviation of variable 1. The standard deviation of heights was 115.2 and the variance was 10.73. I had to use the mean I had already calculated and insert it into the equation using the first number as a measurement in the data, such as 162.5 from the heights of students column. Following with subtracting the mean, in the heights case it was 169.2, and squaring it. The equation would look like this: 162.6 minus 169.2 squared. Completing this throughout the entire column and then continuing to add each. Concluding this, I divided the final number by the amount of data, which was 25, after I had to square root the calculation, and this got my variance, 10.73. Box and whiskers of variable 1. This box and whiskers plot showed me the quartiles in the data. Quartile 1 was shown as 162.5, the median again was 167.5, and the quartile 3 was 176.3. Data variable 2, shoe sizes. In my second variable, I found the mean, 8.4, the median, 8.25, and the mode, 7.5. Again, the mean tells the average, 8.4, the median, 8.25, is the middle number of all the measurements, and 7.5, the mode, is the most common shoe size. Histogram for variable 2. This graph, shoe sizes of students, represents a normal distribution. With zero skew in this graph, it is symmetrical in appearance and has one peak in the middle of the chart. It tells me how many students have each size of shoe. Variance and standard deviation of variable 2. Looking back on the instructions on how to find the standard deviation and variance of the heights, I used the same equation and inserted the numbers from my second column for the shoe sizes. The standard deviation of shoe sizes was 2.48 and variance was calculated as 1.6. Box and whiskers of variable 2. For this box and whiskers of the shoe sizes, it showed me quartile 1 as 7.5, the median, the quartile 2, was 8.25, and lastly, the quartile 3 was 9.25. Scatter plot and line of best fit. After looking at the data collections as individuals, I created another scatter plot graph to show the trend line, also known as the line of best fit. The line of best fit just shows the human eye where the best closest line would go to make it more pleasing and easier to read. The line of best fit calculated as 0.131x plus negative 13.7. This is a strong and positive correlation. R-square and R-value. To find R-square, I added this to the end of the LOB equation and it measured to 0.666. I found the R value in Google Sheets by typing equals Corel and highlighting the first column, which was heights, and typing a comma, and following by highlighting the second column, shoe sizes of data. The value came to 0.8162192835. Residuals. I next compared together the variables in a residuals graph. The graph showed the differences in measurements between each data that I had collected, and the second section of the whole assignment. Conclusion. What I found was shoe sizes and heights of 25 different peers around me. Their heights ranged from 150 to 188 centimeters, and their shoe sizes varied from 4 to 12. In the end, my hypothesis of people having bigger feet because they are taller and people with smaller feet because they are shorter was not entirely right. Earlier, I found how someone with the height of 5'3" and someone else with the height of 5'11" had the same shoe size of 9. These numbers surprised me because I thought it would make sense of having larger feet while being taller to hold your height in the body, not needing as large of a shoe size to hold up your body if you are shorter. The measurements everyone gave me were completely true and primary facts. They had all different heights and shoe sizes, but everyone had something in common, whether it being their height, their shoe size, or even both. This is because people cannot control their own height or shoe size. It is all generated by genetics from their parents, so it is science on people how to get their measurements of height and shoe size. How things went and improvements. I am personally proud of how this assignment turned out. It showed me the differences people around me have in their heights, and it was interesting to know how some people could have the same shoe size but also be completely different in heights. Something better I could have done with my project could have been on my graphs. My graphs were all the same color, which was blue. I could have changed all of the colors to give it a more pleasing look to the assignment. The end.